Nigel, so today we're going to talk about, real quick, the Miasma attack. This new supply chain attack that came out a week or so ago. And I heard that this is from TeamPCP. Is that the same thing as Shai-Hulud? What can you tell us about it?
Yeah, so definitely it's a TeamPCP related variant. And what I mean by variant is we'd seen Shai-Hulud. We know what Shai-Hulud is, which is a self-replicating worm that's coming from these open source registries. When we say it's a variant, basically it's, someone's copied the code and made something more or less the same as Shai-Hulud, doing slightly different things than the original version. So last week we saw, Shai-Hulud was open sourced, or was that even 2 weeks back at this point? Which meant anyone at that point could go onto something like a GitHub or a GitLab, copy the code and make changes to it. So this variant, it's slight changes on the original one. So we've actually seen between Shai-Hulud, there was Hades and now Miasma, and they're doing slightly different things, but it's like having advanced data credential stealing, which might be originally we were looking for NPM credentials, maybe some SSH keys. And now we're actually saying, why not just take all environmental variables from all the different tools? So it's like the idea is lateral movement to other places. And that's the real difference in this one. One step further is that they were able to impact larger organizations. The likes of Red Hat and Microsoft were impacted with this version.
Cool. One of the things that I think you and I have talked about before is that lateral movement you talked about. There's this, it's almost this yo-yo effect. Can you maybe explain what the yo-yo effect is?
Yeah, absolutely. So, if someone were able to compromise a maintainer account, let's say you have a maintainer of an open source project, and that project is just, any project on NPM or PyPy. So if that maintainer, that workstation that they work on is compromised, you have access to, for instance, their credentials that can talk to the upstream registry. So in that scenario, they're able to push malicious code, right, as a new version, let's say, into those registries. Now, when we're talking about that yo-yo methodology, which is we're all pulling open source code from these registries, PyPy, Maven Central, NPM, whatever it be, or even open source registries, repositories as well. So in this scenario, when a user pulls what seems to be a legitimate brand new package from that open source project, they're in this case pulling down malware. Now, if that malware is like run on that person's workstation, then because it's Shai-Hulud, Miasma, Hades, then it's also trying to steal credentials from that person's workstation to then talk to their registry. And so on this cycle of, I can now move from a maintainer of an NPM, a legitimate NPM project. I've now talked to NPM. Someone's pulled it from NPM down to a local workstation. And now I have local credentials to talk to PyPy, the Python package index. And so on the cycle goes of moving to other places and changing the focus of this attack.
Okay, well that's really interesting. So there's the endpoint side and there's the registry side of things. Thinking about the registry side of things, how do companies know if they're impacted or by something like Shai-Hulud, or if they understand what kind of a threat it is?
Yeah, oftentimes it's too late when organizations find out. So quite literally, if you ran some type of a credential stealing malware, you don't necessarily know it's stealing your credentials. But if it's doing something destructive, yeah, you're probably aware that it has now done something bad in your organization. A lot of times we're waiting on these threat researchers to post these security advisories, which tell us these list of software packages in these specific registries are impacted. They'll give us a malware, a malicious package advisory, which will tell us mal-here-unique identifier for that package. And they'll say, this thing is known to be bad on this specific package version. Again, that's very reactive. We've since installed the latest package, and now you're telling me that it's bad. So when it comes to how we deal with this, we really want to do one of two things, which is to wait on these advisories or find creative ways to maybe hold off from downloading the latest thing always, especially if there's not a business justification for always pulling the latest and greatest.
Okay, so there's an interesting point you made there about waiting for these, threat intelligence researchers to find these. So there's a gap, right? There's that 0 hour between when the compromised package goes live and when the intelligence surfaces to be able to detect that. What can companies do in that 0 hour to better protect themselves?
Yeah, no, absolutely. So there's technologies today that, again, these automated fuzzer scanner things that are looking at these public registries, and they can look at public code that exists on, again, public open infrastructure. Sometimes they get the advisory out in quite literally seconds, which is really remarkable that it's all happening so fast. Sometimes it's hours and sometimes it's days, and that is the harsh reality of security. We're always moving faster, but sometimes we're not fast enough. Organizations can take responsive action or proactive steps to deal with this. And the most common step is, you'll hear of this, is cooldown policies. Cooldown policies, whether you do it in the NPM registry or you do it in your private registry, is to essentially say, hey, a package gets published, like you say, N is 0, so it's just been published now. Do I want to define a time window to say, I don't consume or I don't handle packages that are younger or less than 2 days in age? That way, it gives that security research, as we say there, some are detecting in minutes, sometimes in a day or two, but generally speaking, the heavy majority, high in the 90+% of packages are detected and since removed from those public registries within that 2-day window. So the idea of defining a cooldown policy is your way of saying, hey, I don't want those packages that are brand new, yet I still have trust in these open source packages from that specific open source maintainer.
Excellent. Yeah, cooldown policies. I know those are really popular right now, so that's interesting. So one more question real quick. We deal with the registry side of things a lot. So how can a tool like Cloudsmith specifically help to protect against these Miasma-style attacks?
Yeah, so we're dealing in a few ways. The first way is, we wouldn't want software developers today to still be blindly pulling from public registries. There are a lot of registries, there are a lot of repositories, and we just highlighted there with Miasma, Shai-Hulud, Hades, and so many more, is that they are key targets for adversaries out there, which is to compromise a workstation and then publish bad code to these public registries that other people then consume. So what we're offering is, for instance, private registry is a way to say, we'll proxy and cache packages from those public registries into our own registry. Now, why would I do that? It's still yet another registry. Well, we can put additional layers of security on top of that private registry. One is, what you mentioned there a second ago, cooldown policy across all the popular package registry formats. That way, whether it be NPM, PyPy, whatever it is that we pull from, we don't define little individual security controls on each public registry. Instead, we define kind of one strong policy in our environment, and that would apply to all of them that we've cached from those upstreams. Now, that's one of them. But the other thing as well is, as we discussed, that'll address 90% of the incidents. But if we want to explicitly know if something we've already cached is known to be bad, for instance, before we use it, we also want to take that information from those security research, those advisories. So we'll plug into data feeds like open source vulnerabilities, osv.dev, so that we can actually say, hey, look, this package has been known to be flagged as bad, malicious code inside it. It was a type squatted package, whatever it be. In that scenario, we then have policy that says, if the advisories in the, from their public data source, their public database says this thing's bad, then our policy will say, through continuous security, we'll continuously update and say, oh, we actually don't permit people to use bad code, and therefore it'll get quarantined and that's blocked for our developers.
Well, Nigel, thanks so much for all the information. It's great stuff all around, and hopefully it's going to be really useful for a lot of people. Now, if you are interested in protecting your software supply chain, go to cloudsmith.com, book a demo to talk to one of our experts today.